Today is also a special day because we hear two presentations from the two experiments, ATLAS and CMS, on their update on a search for a certain particle.
Conclude by saying that we have observed a new boson with a mass of 125.3 plus or minus 0.6 GeV at 4.9 standard deviations. Thank you.
So, zooming in this region.
We have a discovery. We should state it. We have a discovery. We have observed a new particle consistent with a Higgs boson. Huh. Which one? That remains open. It is a milestone. I think we can all be proud.
Well, I would like to add my congratulations to everybody involved in this tremendous achievement. For me, it's really an incredible thing that it's happened in my lifetime. It's taken... At the beginning, more than 40 years ago, people had no idea about where to look for it. So it's really amazing for me to find out that it's really enough, shall we say, enough for a discovery claim.
We have now found the last missing cornerstone of it, I think. So I'm really happy, and now we also know which direction to go for the future. But first of all, as I said, it's the beginning of a long journey to investigate all the properties of this interesting particle, because if it has a spin zero, if it is a scalar, it would be the first fundamental scalar which we ever have discovered. We have not yet ever seen a fundamental scalar, and that could give a lot of hints on other questions beyond the standard model, and I think this is very, very important, and this is why everybody is not only excited about the discovery, everybody is also excited about the prospects this discovery opens for us, for the field, and for physics in general.
This year's prize is about something very small that makes all the difference. The Royal Swedish Academy of Sciences has decided to award the 2013 Nobel Prize in Physics to Professor Francois Englert at Université Libre de Bruxelles, Belgique, and Professor Peter Higgs at University of Edinburgh, United Kingdom. And the Academy citation runs for the theoretical discovery of a mechanism that contributes to our understanding of the origin of mass of subatomic particles, and which recently was confirmed through the discovery of the predicted fundamental particle by the ATLAS and CMS experiments at CERN's Large Hadron Collider.
Well, I remember I was impressed by of course, the talks of Incandela for the CMS, if I remember correctly, and Fabiola for the Atlas. And they were wonderful talk, of course, and finally it indicates the particle was, the scalar boson was discovered, and in such a way that it was really a proof of all the mechanism. So that was really very impressive, and I like that very much. There is another thing that was rather amusing there, is for the first time in my life I met Higgs there in this place, because he was invited there, I was invited there. Well, it's not a formal invitation by CERN, it was a little bit saying that maybe that would interest you or something like this. And so we understood and we came. And so this was I remember particularly Fabiola great show there, and it was really very impressive. So finally it was clear at that time that the whole thing is going to develop, and the mechanism was right.
Over the past 10 years, ATLAS and CMS have made huge progress in painting the portrait of this very special particle. Today, we know much more about the Higgs boson that we knew 10 years ago. We have understood in detail its production modes and the way it decays, at least to some of the final states. However, the chapter is not closed. The Higgs boson is related to the most obscure part of the Standard Model. So understanding the Higgs boson in detail is absolutely necessary to make progress in fundamental physics.